This is a chemistry revision video looking at how to interpret a chemical symbol formulae. If you look in the description below, there's a link to a worksheet that accompanies this video. By the end of this video, you should be able to look at the chemical symbol formula for a substance and identify whether or not it's a compound. You should be able to calculate the number of atoms of each different type in a compound, and you should also be able to do this where the chemical symbol formula involves brackets. There are only just over 100 chemical elements, but there are millions of different compounds because these elements can be arranged together in different ways. A compound is a substance that contains more than one element, in other words, more than one type of atom, and these must be chemically combined or bonded together in fixed proportions. This means that they can be represented by a chemical formula. For instance, H2O refers to molecules that contain 2 atoms of hydrogen and 1 atom of oxygen, while CO2 refers to molecules that contain 1 atom of carbon and 2 atoms of oxygen. Each one of the 118 elements listed in the periodic table of elements has a code, and this allows scientists who speak different languages to easily understand each other and also makes for a much faster shorthand when we're talking about complex molecules. Each one of these elements has a code that is either 1 or 2 letters long, and the first letter is always a capital letter. If there's a second letter, then it must be lowercase. So for instance, in the symbol for lithium, the L is a capital L, but the I is a lowercase I. You can identify a compound from its chemical formula because it will have more than one capital letter, and each capital letter represents a new element. Many compounds contain more than one atom of a particular element, and so we use small subscript numbers to show how many atoms of each type there are. For instance, this molecule is called glucose, and what the symbol formula tells me is that it contains 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Here are some examples for you to have a go at. You'll need a copy of the periodic table to tell you which element each symbol stands for, and then you can use the subscript numbers to tell you how many of each atom type there are. Pause the video, write down some answers, and then press play when you're ready to check them. Butane contains 4 atoms of carbon and 10 atoms of hydrogen. Aluminium oxide contains 2 aluminium and 3 oxygen. Hydrogen peroxide contains 2 hydrogen and 2 oxygen. And chromium oxide contains 2 chromium and 3 oxygen. Some compounds only contain 1 atom of a particular type, and chemists are kind of lazy, so we basically never write the number 1. We never use it when we're balancing symbol equations, we never use it when we're writing ions, and we don't use it in chemical symbol formulae. So if you see a capital letter that doesn't have a number after it, this means there's only 1 of that atom type. So here, in carbon dioxide, there's only 1 atom of carbon per molecule, but 2 atoms of oxygen. Here are some more symbol formulae for you to practice interpreting. Pause the video, write down your answers, and then when you're ready to check them, press play again. In each mole of water molecules, there are 2 moles of hydrogen atoms and 1 of oxygen atoms. In a mole of magnesium chloride, there is a mole of magnesium ions and 2 moles of chloride ions, which have come from chlorine. Calcium oxide is 1 calcium to 1 oxygen, and lithium hydroxide is 1 lithium to 1 oxygen to 1 hydrogen. The most complicated part about interpreting symbol formulae is when we start to introduce brackets. These brackets are used to indicate groups of atoms that come together as a kind of package deal. So this compound here is called magnesium nitrate, and it's made up of magnesium and something called a nitrate ion, and that nitrate ion has a nitrogen atom and 3 oxygen atoms, and there are 2 of that nitrate ion. So we use the brackets, and then the 2 applies to the entire bracket. So you could think about writing this out as MgNO3NO3, because NO3 happens twice. When you're thinking about how many atoms are included in the compound, it can often be very helpful to write it out longhand like that and actually repeat the bracket. So what this symbol formula tells me is that there's 1 atom of magnesium, because magnesium doesn't have a number next to it, and it's not inside the brackets, so the 2 doesn't apply to it either. Then we have 2 of this NO3 bracket, and each one contains 1 nitrogen and 3 oxygen. So in total I have 2 nitrogen and I have 6 oxygen. 3 in the first bracket and 3 in the second bracket. Here's another similar example, aluminium hydroxide. So what this symbol formula tells me is that I have 2 atoms of aluminium and then 3 atoms of oxygen and 3 atoms of hydrogen, because that hydroxide bracket, that OH, is happening 3 times. Here are 5 symbol formulae of that final type for you to practice interpreting. Remember, the number next to the bracket applies to the entire bracket, and if you're struggling with figuring out how many of each atom type there are, it can often be helpful to just write out the bracket as many times as the number says you should. Pause the video, write down some answers, and when you're ready to check them, press play again. In calcium hydroxide, there's 1 calcium, because there's no number next to the calcium, and then 2 oxygen and 2 hydrogen, because they're both inside the bracket, so the number 2 applies to both of them. In vanadium hydroxide, there's 1 vanadium, because again, there isn't a number next to vanadium, and then 5 oxygen and 5 hydrogen. In zinc nitrate, there's 1 zinc, 2 nitrogen, and 6 oxygen, because remember that whole NO3 bracket is happening twice. In chromium sulfate, there's 1 chromium, 3 sulfur, and 12 oxygen, because the whole SO4 bracket happens 3 times. And then in ammonium phosphate, there are 3 nitrogen, 12 hydrogen, 1 phosphorus, and 4 oxygen. Thank you very much for watching, and I hope you found that a useful introduction to how to interpret chemical symbol formulae. If you did find it useful, then don't forget to like and subscribe for more chemistry revision videos coming soon.